Okay, so this lesson is going to be part of section 1-3, which is talking about functions and function notation. So this one is probably going to have a little bit more writing than some of your other ones, so you might be needing to pause a little bit more to make sure that you're getting all of the information that you need written down. Okay? So make sure you're doing that. Okay, so a function f from set A to set B is a rule of correspondence that assigns to each element x in set A exactly one element y in the set B. That's the definition of a function. So we've got two sets, set A and set B, and a function is a rule that assigns one element in set A. We call those x, to one element in set Y, or set B, excuse me, and we call those our Y values, okay? Set A is the domain, also known as the inputs. So we use those words interchangeably. We say domain, inputs. Set B is the range or the outputs. Okay, on page 133 are the characteristics of a function. So, take a minute and turn to page 133. There are 3 of them, and I'm going to write them down, and I suggest you do the same. Each input must have an output. Okay, so if it's in set A, then it has to have an output. Okay. Some outputs may not be matched with an input. Okay, so notice rule 1 talks about how each input has to have an output. However, the reverse is not true. That's what that second statement is saying. Just because it's an output does not mean that it's going to have an input. And the third thing, 2 or more inputs can have the same output. Okay? A little rule that also goes along with number 3 is that you cannot have an input with more than one output. Okay, so an example of number 3, 2 or more inputs can have the same output. A function that meets this rule would be y equals x squared. That would be an example of number 3, because 2 squared gets me 4. Negative 2 squared also gets me 4. So that's okay. I can have 2 or more inputs with the same output. However, I cannot have an input with more than one output. Okay? What we're going to do is we're going to look. There are 4 examples on page 134. So turn to that. Now might be a good time for you to stop the video. What it's going to do is it's going to ask you, of those 4 examples, which ones are ordered pairs and which ones are not. So it might be a good time to stop and see if you can do that by yourself. Okay. So look at it's example 1 on page 134. Then if you look, it's A, B, C, and D, and below that is your solution. So I want you to take a second to look at that example. Okay. The ones that are not functions are letter B. Letter B is not a function because if you look up in set A contains the elements A, B, and C. And if you look at set B, letter B, okay, there's no C input value. So that's why that is not a function. Each input must have an output, so it fails letter 1. Okay? C is not a function. C is a function. It's okay if every single input goes to the same output. We would just end up with a straight line, like a horizontal or vertical line if we had that happen. Okay? D does not represent a function because element A and element B have more than one output, and we can't have that for a function. Okay? So, last thing I want to talk about in this section is function notation. Or not in this section, in this video. Okay? Function notation. X are your inputs. Okay? F of X are your outputs. And all f of x was normally replaced as y, and that's just showing that those are your outputs. Okay? So, this is red. F of x, or the value of f at x. Okay? So that's red. F of x, or the value of f at x. So it would look something like this. Here's an example of an equation that is written in function notation. So we've got that f of x instead of y equals. Okay? Other common ways, instead of having an f, you could see g of x or h of x. So you can see all of those things. Okay? Next thing I want to talk about is evaluating a function. Okay? So we've got our function f of x equals 3 minus 2x. And I want to know the value of f at -1, the value of f at 0, and the value of f at 2. Okay, and this is exactly what you guys are used to. We're just substituting our x value in to our function and evaluating. So this would be 3 minus 2 times negative 1, okay, which is 5. Okay, now would be a good time, pause, do the other two. So we can evaluate a function at certain numbers like we just did in the previous example. We can also evaluate a function. So my new function is going to be g of x squared equals negative x, or g of x, equals negative x squared plus 4x plus 1. And I want to evaluate that at g of x plus 2. So what that means is everywhere there is an x, instead of just having x, I'm going to write x plus 2. So here, instead of x, when I do g of x plus 2, it's going to become negative x plus 2 squared plus 4. And this is important that you put this in parentheses because that 4 is being multiplied by x. So I need to make sure 4 is multiplied by both x and 2 plus 1. And then this is just a matter of simplifying. So maybe pause and simplify this before you go on. So we've got negative x plus 2 times x plus 2 plus 4x plus 8 plus 1. Okay, so I'm going to go ahead and FOIL this out. You should end up with a negative times x squared plus 4x plus 4 plus 4x plus 8 plus 1. Okay. All of these signs are going to need that negative in my parentheses. And then I just need to combine like terms. So I've got negative x squared, can't combine with anything. Negative 4x and 4x are going to combine. Negative 4 and 8 and 1 is going to make 5. So we've got negative x squared plus 5. Okay, so that would be evaluating a function. I can either evaluate it with just numbers like we did up above, or I can evaluate it with an expression. So that expression would replace all of my x values. Okay, last thing for this video is piecewise functions. Piecewise functions, okay? These are defined by 2 or more equations over a specific domain. Okay? So, we've got 2 or more equations. So an example of a piecewise function would be f of x equals x squared plus 1. And here's my specific domain. This happens when x is less than 0. And then I want to say x minus 1 when x is greater than or equal to 0. So those are my specific domains. Okay. Now, I want to evaluate this piecewise function at x equals -1, 0, and 1. So the key to this is making sure you're picking out the correct part of your piecewise function. So here, we want to evaluate when x equals -1. So which one of these would I use? Well, x is less than 0 is this function, so I should be using x squared plus 1. So the value of f at -1 would equal -1 squared plus 1, so that would be 2. Okay? When x is equal to 0, which part of your function would you want to use? Here's my specified domain. X is greater than or equal to 0, so I know I would want to do 0 minus 1, so that would be -1. If you had used the other one, you would have gotten a positive 1. So you have to pay attention to which piece of the domain, or excuse me, of the function you need to be using. And at that 1, well, this is x is greater than or equal to 0, so that would be 1 minus 1, and I would get 0. Okay, so that is a basic overview of functions, function notation, evaluating functions, and piecewise functions.